When we talk about infrastructure and modern technology, we are no longer just talking about servers sitting inside an isolated data center or local workstations connected to an office Wi-Fi. Today, the entire physical world is transforming into a massive, interconnected network. Entire metropolitan areas are linking their transportation networks, energy grids, and public utilities directly to the cloud. We are moving rapidly into the era of the smart city. Hello, everyone, and welcome back to Radio Computer Tech English. I am your host, Brian, and I am so happy to be here with you. Today, we have a highly futuristic and critical infrastructure episode for your listening practice: how to talk about smart cities and IoT integration. In this episode, we will maintain a steady, natural, and continuous recording rhythm throughout the entire script, allowing you to train your ears effectively. The language will blend everyday corporate English with advanced networking and sensor architecture terminology. Sit back, listen to how engineers connect physical environments to the cloud, and let's upgrade your technical ears. Let's step into an urban planning and technology sync. A senior enterprise solutions architect is presenting an IoT framework to municipal stakeholders and network operations managers.
Good afternoon, everyone. Thank you for joining today's Infrastructure Development Roadmap. As urban populations expand, traditional city management systems face severe bottlenecks regarding resource allocation, energy consumption, and traffic congestion. To resolve these challenges, our engineering team is launching a comprehensive smart city initiative centered around the deployment and integration of the Internet of Things, or IoT. When we talk about IoT integration on an urban scale, we are talking about embedding millions of smart sensors, actuators, and smart meters directly into the city's physical fabric. Let's look at grid modernization as our primary example. In a legacy municipal system, tracking water leaks or power outages is reactive. We have to wait for a citizen to submit a complaint. In our new smart infrastructure, automated flow sensors constantly stream telemetry data back to a centralized management portal. However, streaming raw data from millions of local endpoints simultaneously creates massive network latency and saturates our cloud storage bandwidth. To solve this architectural bottleneck, we are deploying an edge computing framework. Instead of sending every single data packet across the public internet to a distant data center, microprocessors located right inside the street-level hardware handle the initial data processing. They filter out the background noise and only transmit critical anomalies or resource alerts to the main server, optimizing our bandwidth utilization and speeding up our system response time.
Now, the presentation transitions to the exact communication protocols required to connect these citywide devices and addresses the critical cybersecurity risks of public infrastructure.
Now, let's look at the underlying network layer that keeps these distributed sensors connected. Standard Wi-Fi or cellular networks consume far too much power and have a limited coverage footprint. For thousands of small, battery-powered devices, like smart parking sensors buried in asphalt or environmental monitors attached to streetlights, we are implementing a protocol called LoRaWAN, which stands for Long Range Wide Area Network. LoRaWAN operates on a low-power, low-bandwidth architecture. It allows a tiny sensor to transmit data over several kilometers while running on a single battery for up to 10 years without any maintenance. However, scaling our public infrastructure across the web introduces a massive, vulnerable attack surface. If a malicious actor or hacker gains unauthorized access to our traffic control subnet, they could manipulate traffic signals, create gridlock, or disrupt emergency services. To protect our urban canvas, our security team enforces a strict end-to-end cryptographic encryption model. Every data packet traveling from a street-level sensor to the municipal cloud gateway requires mandatory authentication. Furthermore, we are implementing automated endpoint protection that monitors device telemetry in real time. If a sensor behaves erratically or exhibits anomalous communication paths, the network architecture instantly isolates that specific node from the main network perimeter, ensuring the rest of our smart city infrastructure remains secure, resilient, and completely stable.
What a forward-thinking and sophisticated infrastructure presentation. Now let's review 5 critical smart city and networking terms from today's episode to sharpen your professional vocabulary. 1. Edge computing, a distributed computing framework where data processing is performed close to the physical location of the data source, rather than entirely inside a centralized cloud server. 2. Telemetry, the automated process of collecting, measuring, and transmitting real-time data from remote sensors or devices to an internal monitoring system. 3. LoRaWAN, Long-Range Wide Area Network, a specialized low-power, wireless networking protocol designed for secure long-range communication between battery-operated IoT devices. 4. Attack surface, the total number of points, endpoints, or vulnerabilities in a system where an unauthorized user or cybercriminal can try to enter or disrupt the network. 5. Node, any physical device, sensor, or server connected to a larger network infrastructure that is capable of sending, receiving, or forwarding data. Thank you for practicing your technical listening skills with me today on Radio Computer Tech English. Learning how to articulate the value of IoT integration while confidently explaining data pathways and security perimeters is an invaluable skill for any modern infrastructure engineer or software leader. Is your current engineering team working on distributed IoT projects, or are you focused on traditional localized cloud infrastructures? Let me know your deployment experiences in the comments section below. Don't forget to hit the like button, subscribe to the channel, and share this podcast with your engineering network. Keep listening, keep learning, and I will see you in our next episode. Bye-bye.